The overall goal of this procedure is to prepare nanofibers decorated with functional groups. First, synthesize a block copolymer of 2-methoxystyrene and ethylene oxide via anionic polymerization, and characterize it by proton NMR spectroscopy. Next, electrospin the functional polymer and single-wall nanotube solution into a composite nanofiber. Then determine the current voltage behavior of the nanofibers after they have been exposed to the protein IgE. Ultimately, combining the anionic living polymerization with electrospinning can produce nanofibers decorated with functional groups that are capable of binding to specific proteins.
In this approach to fabricating biofunctional nanofibers, anionic living polymerization permits the facile synthesis of biofunctional polymers with controlled molecular weights. Further, electrospinning technique permits the preparation of nanofibers decorated with functional groups which can specifically interact with proteins.
This method can provide valuable insights into medical diagnostics. It can also be applied to other systems such as the monitoring of any single molecule desired in the environment by incorporating functional nanofibers into clothing, automobiles, etc.
Anionic polymerization requires extremely stringent conditions.
This video should help you master the manipulations necessary for the synthesis of a polymer and subsequent processing into a nanofiber.
Using benzophenone as indicator, dehydrate 200 milliliters of tetrahydrofuran over sodium metal under dry nitrogen gas. Also dry